So I was told by Ms. Lee that you are doing a bit of a recap of similarity. Last time you did proportionality. So tonight we're going to look again at similarity. So let's jump right into it. And we've got our first problem on the board, and she's given me instructions on exactly what to do, so we'll follow her plan here. So I'll do an introductory example for us, and then I'm gonna put you on the spot and have you try. So we'll basically we'll see how far we get. We might not get through everything tonight, but we'll do our best. And it's not really about how fast we go. It's just as long as we understand what is going on. Rightio. So, first of all, when you get a geometry question like this, make sure that you read everything that is written there, because sometimes some of the important information is written down, but it's not on the sketch. So don't just assume that everything is already indicated on the sketch. So it says here in triangle PST, TS is perpendicular to PS. Okay, so great. That gives us that 90-degree angle there, and it makes it a 90-degree triangle. And RQ is perpendicular to PT, also good because it gives us that 90-degree angle there. So what I normally suggest, and this is also just like personally how my brain works, get some colors, get some highlighters, and start off with highlighting the two triangles that you need to prove similar. So in this case, it's PRQ, and that's the green one. And I'm going to make the other one PST, the big blue one. If you can hear that noise in the background, it's just my dog missioning around the house.
Oh, we can't hear anything.
Can't you hear it? She's up and down pacing. Okay. So when we prove similarity, we need to prove that three angles are the same. But actually, it's only necessary for us to prove two, because the third one follows from the fact that the angles in a triangle add up to 180 degrees. So before we start our proof, let's just look for those angles, if we can find angles that are equal and for what reason. So if you don't know where to start, always start with what is given. So what is given is that this is 90 degrees. Okay, not much we can do with that information, but we can do something with this information. This one is also 90 degrees because this line's perpendicular to that one, which is going to make angle R1 90 degrees as well. And the reason for that would be angles on a straight line. So there's our one angle. Yay. So the next thing, because R1, sorry, I must just be specific, R1 is going to be equal to angle S over here, because they're both equal to 90. Okay, one angle down. We need one more. So the other angle we can look at is angle P. I'm going to make a dot here. Angle P in the green triangle overlaps with angle P in the blue triangle. And that is because they have the same vertex. So they share that angle. That makes it a common angle. Some people find this quite confusing, like what is a common angle? That's basically the description of a common angle, is that they have this overlap or this shared vertex. And that's my other angle. So there's two angles. So the last one, we don't even have to really bother about. We can just say that Q2 is going to be equal to angle T because of the interior angles of a triangle, or the angle sum. So when we do our proof, we're going to start off very nicely in triangle PRQ and triangle PST. And many people say, do I have to do this? Is this worth a mark? No, it's not worth a mark, but it does help to structure your proof very neatly and logically. And if you can do that, then your thoughts are structured. So then it's not all over the show. Okay, so write that down because that's also going to come in later, quite useful. So first of all, we can start with angle P. Angle P is equal to angle P. And why is that? Because it's a common angle. Common angle. That's my reason. Then my second reason, you're going to need to just explain a little bit this story here about how that angle is 90 degrees because it is given, it's a given piece of information. So R1 is also 90 because of angles on the straight line. So R1 equals 90 degrees, angles on a straight line. And therefore, R1, not P1, but R1 is equal to angle TSP. TSP. And that doesn't require a reason because they're both equal to 90. So it's kind of obvious. And then the last one is just going to follow from the fact that the previous two we've figured out already. So Q2 is equal to angle T, and that is angle sum of a triangle. Right, then we end off and we say triangle PRQ is similar to triangle PST, and the reason here is angle, angle, angle. Right. Okay, so any questions so far? Anyone happy with what we've got? If you're happy and you're following along, put a thumbs up in the chat. And if you're not so happy, don't be scared to ask a question.
Yes,
put a thumbs up in the chat if you're happy.
Yeah. We are here to help.
Yeah, awesome.
Yes,
Is R1 not 90? It was given as perpendicular. Can we say that? They did give us, I think to play it safe, let's just say they gave us TRQ because that one was indicated as 90. So if the one's indicated as 90, then the other one is also 90 because of angles on a straight line. So rather play it safe and put it that way.
Yeah.
Alrighty. Okay, so after we've done the similarity, the following questions, anything you see that looks like this with the ratios and stuff now has to do with the fact that the triangles are similar. And what do we know? What do we know about the sides of triangles that are similar? What can we say about them? Put it in the chat if you know. What can we say about the sides of triangles that are similar? What do we know, guys? Put it in the chat. What's that word?
Let's go, guys. Remember, you can say whatever, and then Miss B is here to definitely correct us. Okay.
Nice.
Really see some nice answers.
Okay, so why is everyone so scared? Because there's all these right answers coming through. Yeah, so the sides are in proportion. Okay. So what does that mean? That means that if you divide the sides, say those sides had numbers attached to them, and if you divided them, you get the same answer each time. That's what it means that the sides are in proportion. So the ratios of the sides are equal. So when you get to this part, you need to just start thinking about that, the fact that the sides of similar triangles are in proportion. Okay, now in the other class, I asked if they knew the frog face, and they said no. So I showed them the frog face. I wonder, Ms. Linda, does this class know about the frog face?
Not sure. Do you guys have heard anything about the frog face? Because it's such a coolest thing I've ever heard. You would love it. You see, everyone is saying no. Guys, get ready. Ooh, Lisette says they know. Frog face, yes, I understand, right? You'll be shocked though. Just watch out. Okay, guys, let's be ready for it. Let's listen. You'll be so shocked. I promise you.
Are we really building it up, eh?
I was so shocked. That's why I'm like, they will have to be shocked also. Oh, equal brokers.
Are you in the wrong class? I don't know. You should be in grade 12 class doing proportionality and similarity. Okay, so what we're going to do now is work with our sides that are in proportion. So the frog face is just like a funny little thing to do to help you. Yes, I'm standing in for Miss Lee. Yeah, she'll be back on Tuesday. Yeah.
Surprise,
So the frog face is just something that you can do to help you find the sides that are in proportion, to write down your ratios. Okay. So, and that's the first part to answering this question. I think it is the best part, the best way to do it, because to just try and figure out doesn't help. So what you need is for the corresponding sides to be in proportion. So when triangles are similar, the corresponding sides are in proportion. How do we find the corresponding sides that are in proportion? Well, we say PR, and you make that's the first eye of the frog, and you go to the other triangle over PS, and you make the first eye. Then you make the next eye, RQ over ST, and then you make the mouth, PQ over PT. And then you have your sides that are in proportion because of the similarity, and you've got a little funny frog face. That's where it comes from. Yeah, maybe you've called it something else.
I was also so surprised. But it works every single time, guys. That's amazing.
If you've got everything set up correctly in corresponding order. Okay, so these are my sides that are in proportion. Those are the corresponding sides. So PR is corresponding with PS, RQ is corresponding with ST, and so on. The reason for that, you must give your reason, is that triangle PRQ is similar to triangle PST. That's the only reason why those sides would be in proportion for these two triangles. Okay, now that is where we start to do questions like this. Now, what do we need? We need RQ. We need to prove that RQ to PQ is ST to PT. Now, remember, this is written in ratio form. We can change that and write it as fractions, because fractions are the same as ratios. So what I'm going to do is I'm just going to write it here sort of as a little note to self. Oh, there goes my electricity. RQ, what I need to prove is that RQ to PQ is equal to ST to PT. Now, how am I going to make that happen? So I go to where I set this up and I look for the sides that I need. Okay, I need RQ and PQ. There's RQ and PQ and ST and PT. Okay, awesome. So this is the combination of sides that I'm going to work with in order to prove this. Okay, so we have to make this look like that. And how am I going to get that right? So that's just a matter of changing the order around a bit. And remember, we can do that with the ratios and the fractions. We can change and juggle around by using cross multiplication. So the fractions I get from doing the corresponding sides with the frog face. So it's PR to PS, RQ to ST, and PQ to PT. Those go together. Okay. So how am I going to get that to look like this? This is what I need to prove. Now we can write this as a fraction as well, just so that we have like for like. We have the same, we're looking at the same things. So RQ, we can always go back again and change it to a ratio again. But this is basically what we need. Okay, but this is what I've got at the moment. So how can I change this around to look like this? Does anyone have any ideas? Any ideas? How can I get RQ over ST equal to PQ to PT to be RQ over PQ equal to ST over PT? How can I do that?
Oh, my people, y'all can come up with some nice things. Whatever you're thinking about, whoa, look at that.
Reciprocating, I think I can see where you're going, but there's something simpler. The other class knew, they knew straight away. Hey, Miss Yolanda.
They did. It's just the wording, but I'm sure Tsakofato means the same thing, but it's just the wording that there.
Yay!
I'm glad. So happy. Happiness. Well done, Tsakofato. That's really nice. I knew you meant it like that.
Good stuff. Okay, so we're going to go RQ times PT. So cross multiply like that and cross multiply like that. PQ times ST. And we want the PT to be here with the ST and the PQ to be with the RQ. So we want those ratios. So then we're going to divide RQ over PQ. And this side we divide by PT. Well, we divide both sides by PT. But they asked for it to look like this. So we have to answer with the format that is required. RQ to PQ, ST to PT. Okay, so all of this just comes about from your sides that are in proportion, your corresponding sides that are in proportion, and just juggling them around and either putting them in ratio form or fraction form and just changing the order through cross multiplication. That's all you're doing, guys. So whatever they ask you here, and it can get complicated, but that's the basic. That's what it comes down to in the end. Okay, we've got one more here to do, PR times PT. And then it's going to be your turn. I'm going to do this one over here. Question C. By the way, I can't claim that the frog face is my original idea. There's a very smart man called Mr.
You brought it to us, so we will remember. Miss B gave us frog face.
There's a very smart man called Jörg Passon, and he taught me about the frog face. So
That's nice.
Okay, so we're still working with these two triangles. So we're still using our, I'm going to go grab it over here so we don't have to rewrite it. Okay, so we're still working with that, and that's going to help us now to do the next one. So we need to show PR times PT is PQ times PS. So this one is fairly straightforward, a little bit more straightforward. We look at what we need at the end and we find our combo that goes together. So here's the PR and PS, and then there's PT and PT and PQ. Yeah, there's PQ and PT. Okay, so it's that. So do you guys see if I just cross multiply PR over PS with PQ over PT, then I'm going to get what I need. So let's try that. So PR, so you write down PR over PS, not BS, PS is PQ over PT, cross multiply PR with PT and PQ with PS. All right. And that's done. That's what we needed. All right. Any questions? Let's
Just take screenshots. I'm not sure how they're gonna juggle it, but guys, please take screenshots. For those of you who were not writing yet, feel free to take screenshots.
Okay, so I'll put it there with A and C. That can be one screenshot.
Yeah. And see how I hope that question got answered because we just did the cross multiply.
And here's question B. Alrighty. Right, the next one is your one. And I'm going to leave you here for a bit to grapple with it and to figure it out. You're going to need your knowledge of parallelograms and the properties of parallelograms. It will come in handy to do this one. And then once you've done your similarity, remember for similarity, 2 angles. And then once you've done your similarity, you can tackle the questions about the sides, and that just has to do with the fact that the corresponding sides are in proportion. And try your frog face. Maybe it's helpful. But we'll be here. I'm going to leave you to fight with this one for a little bit, and then Miss Yolanda and I will be here if you have any questions. I would start this one. First read everything that they say at the start and then fill it in on the sketch. So if you can quickly make a copy of the sketch there where you are, just in pencil or something, and then start filling in the properties of a parallelogram that might be useful in this case. Focus on the angle properties and the fact that the sides, the opposite sides, are parallel. And then highlight your 2 triangles that you're trying to prove similar, and then try and find 2 angles within those 2 triangles that are equal. That's a mouthful, but that is the strategy, okay? It's like charting a course.
Let's go, guys. We can definitely do it. I couldn't wait to actually do number A. I mean, number B and C always because of the frog face. And for number A, I already like now know that to prove similarity, you just need like 3 equal angles. And and the third one actually doesn't really matter because it will always be the same since all triangles need to add up to 180. So guys, those are like real nice tricks that we need to remember. So Riabedzwe, how we begin, probably if I was you, because of course, Miss B is a good teacher, okay? So you first highlight the triangles of what she taught us. So please take a highlighter, draw the thing, like even if it's not proper, take a highlighter and highlight the ones that you're working at and look at the previous example and just follow that. That's all that you need to do. And more or less just do it in your head, like, oh, which angle equals to which angle, and then you'll be fine. Then you just follow the example and how she taught us to prove it. That's how I got it. I was like, yeah, Miss B, thank you. I'm so happy and grateful. These things used to give me a headache, guys. So you're not alone. I feel for them, Miss B, because I was like, oh, I knew that this was some difficult thing in math to do.
Yeah, it's not easy, but we can do hard things. It's the hard things that make us grow. It challenges us. That's how we grow.
You're making it look like a bag of chips. I always say that. That is like eating a bag of chips. Like, oh, I'm just snacking with this maths, in this maths problem. So give it a try, guys. And please let us know on the chat when you're done with all the 3, okay? So that Miss
let's
B
see
can,
when you're done.
Yeah.
I really think you must give this a proper go, hey? So start with the properties of a parallelogram, fill it in on the sketch, fill in everything that they've given here. There's a lot of things given here that's not filled in on the sketch. So fill it in on the sketch. Then use what is given. That's the other thing. That's the other tip with geometry. If you don't know where to start, start with what is given. Because they didn't give you that information for nothing. Okay, so we're about 6 minutes in. Let's see if we can finish up. Maybe someone can let us know if they are done. I'm burning to help, but I also know that you must try on your own. Okay, let's have a look, guys. So they say here that ABCD is a parallelogram. So the first thing you need to do is pause and start putting some of the properties of the parallelogram, indicate them on the sketch. What are the properties of a parallelogram? You need to know these because anything you've learned in high school, especially since grade 10, 11, and 12, that can be asked. So the properties of a parallelogram, we say that's assumed knowledge. Everyone assumes that you know that the opposite sides of a parallelogram are parallel. Okay, so that's great. I love parallel lines because they just give us angles that are equal. Okay, next part is that BE is equal to BC. BE, this one here, is equal to BC. And then it also says that BD is equal to AB. BD is equal to AB. Now that's even better, because what happens is that if you have these sides that are equal, it forms isosceles triangles. So you have angles opposite equal sides, angles opposite equal sides when you are working with isosceles triangles. Okay, so there's that. Now, what are some of the other properties of a parallelogram? So we have that especially focusing on the angle properties, because when we are working with similarity, we are looking for angles. So your sides are good, but sides are not as important as angles when we are doing opposite angles. Okay, so the opposite angles of a parallelogram are equal. So we can already say that this is x and that's going to be x. Okay. Let's do the other important part and highlight our two triangles that we are trying to prove. So ABD and CBE. Okay, so let's do ABD. And CBE. CBE. Okay, so there's my two triangles. Okay, now I already have x and x, the angles that are equal because of the opposite angles of a parallelogram. Now the next part, again, I say use what is given to find the angles, because that information wasn't just given in their clues. That information was given because it is there to help you find the equal angles. So I'm going to use these two sides that are equal, and that's going to make this one x as well, and this one x. This one is x because of angles opposite equal sides, and this one is x because of angles opposite equal sides. And there I have my two angles. The third one, B1 and B3, is going to follow from the fact that the angle sum of a triangle is 180. Rightio. So now we need to write all of that down. So we say in triangle ABD and triangle CBE, the first statement I'm going to make is that angle A is equal to angle C because of opposite angles of a parallelogram. The reason is never properties of a parallelogram, because you need to be specific. Which property are you using? DB is equal to AB because it is given. It's written here. That's why it's super important that you read what is written above. Okay, so second thing I'm going to say is exactly that BD is equal to AB, and that means that angle D1 is equal to angle A. So let's go there. Let's do that. D1 is equal to angle A, angles opposite equal sides. And again, there's no such thing as isosceles triangles for a reason. The only acceptable reason is angles opposite equal sides. And then we do the same in the other triangle, where we can say, so D1 is equal to A, and then we're going to say, not making my third statement yet, I'm still just finding another angle that's the same. So then we're going to say that angle C is equal to angle E2 also because of angles, opposite equals sides. And therefore, angle D1 is equal to angle E2. So they're both equal to x. So you don't need a reason there. It just follows logically. That one is x and this one is x. And then you can say the third one is that B1 is equal to B3. And that is angle sum of a triangle. And because we have these three angles that are the same, we can say that the two sides of the two triangles are similar. Okay, so now we need to answer these questions about the sides. So we need to do AB to BD. I'm actually going to do B here. So we need to prove angle side is not a reason for, sorry, I should have put my reason here. Angle side is not a reason for similarity. It's a reason for congruency. So let's not get those mixed up. Okay. Angle is the only way to prove, well, it's not the only way. The other way is to prove that the sides are in proportion, but in this case, yeah, so angle, side, those are not relevant to, and I think as a starting point, you guys need to get that clear. What is the difference between congruency and what is the difference between similarity? And then you need to be very clear about how you prove similarity and what similarity gives you. Similar triangles give you sides that are in proportion, and congruency gives you something like that's a whole nother different thing. Okay, so you need to become very clear about what is what, how to prove it, and what you're looking for. Okay, and just if you follow the lesson and if you follow Miss Lee's lessons as well, I'm sure this will become clearer to you. Okay, so what we need to prove now is that AB times BE is BD times BC. Now, like I said in the first example, this all has to do with the fact that the sides are in proportion. So we're going to write those sides that are in proportion as the starting point. Okay, how do I start this question? I started by writing down the sides that are in proportion. And for that, you can use your little tool called frog face to write the sides so that you don't make a mistake in writing those sides down. So I'm just going to work from here, AB over CB. Okay, so that means AB and CB are corresponding. Next set of corresponding sides that are in proportion is BD to BE. The next set of sides, AD, so you make the little mouth there, to CE. And for this, you need a reason. So for this, the reason is that triangle ABD is similar to triangle CBE. No other reason. It's the fact that the triangles are similar. That's why you've got the sides that are in proportion. Okay, now we look back again. What do I need? I need AB and BE, and I need BD and BC. So which set of sides is going to give me those, are going to give me those sides in my answer? These ones here. AB and CB and BD and BE. And how will I get it to look like that? AB times BE, BD times CB. I can cross multiply. So to get it to look like that at the end, which is what we need to prove, is we just do the cross multiplication. And that's basically all you're ever going to do with these questions. You just do the cross multiplication. Could we mention that DA is equal to CB in the first question, as that is a property of parallelograms? How is that? So you need to always think strategically. So yes, that's true. They are, but how is that helping you prove similarity? So that is what you need to think. Yes, I've got that property, but at this point in time, that property of the parallelogram is not useful to me because it's not helping me prove the similarity. What is useful to me is the fact that the opposite angles are equal. That was the first key that unlocked the puzzle, is that the opposite angles are equal. And then we worked with the opposite angles and the opposite sides. It depends on what you are trying to prove and what the question is. So it's about using the properties and the information that's there to arrive at a conclusion. And if the information is not relevant, then you don't use it. Just because it's there doesn't mean you're going to always use it. Like here we had two sets of parallel lines, but we didn't use it. There's another question where we do use our parallel lines. Okay, so yeah, make very sure that you only don't get distracted. There's a lot going on, so that's why if you're not clear in your mind about what it is that you need to prove similarity, you need 3 angles. That is your mission. That is what you need to go and find. Don't get distracted by the rest. AD over CE. Again, we're not using it here. We are only using AB over CB and BD over BE. So AD over CE is still there. We're just not using it to answer this question, but it's still there. Maybe we're going to use it in the next question. Let's see. BD over AD equals BE over CE. Now already you can see that we are going to need to use this combo of sides. BD, we have BD, BE, AD, and CE. That combo of sides together, now it's just a matter of juggling. Oh, we don't even, yeah, we do have to juggle. Okay, so the first part is to identify which sides it is that you need, and then look, how do I need to change the proportion around to make it look like what I need to prove. So BD over BE is AD over CE. What do we need? We need BD over AD. Okay, so my AD is in the wrong place at the moment. We need to somehow manipulate it to get it in the right place. Basically, BE and AD need to swap places. How can we do that? Cross multiplication. So BD times CE is AD times BE. And I need BD over AD. So now I'm going to divide again. BE over CE. Done. So for B, it's basically looking at similarity with sides in proportion for B. Yes, so your sides that are in proportion, that follows from the fact that the triangles are similar. So be very clear on that as well. Only once you've proven the similarity are the sides in proportion, and can you do your frog face and write down these proportions, these fractions basically. Only once that is done can you do that. Okay, so then you look for the combos and you just change them around through cross multiplication. And later on replacement. There's also examples where you have to replace one side with another, but that's in more complex examples. But for now, let's try and get this right. So, so I hope I answered your questions, Wanaka. Okay, you can take some screenshots again, and I think we have time for one more. Time has just flown. Miss Yolanda.
Yes, of course. It's just gone by. Like, I don't even know what happened. But they have interesting questions. I was like reading on the chats and trying to answer, and I'm like, whoa, okay, are flowing. I'm wide awake. I'm happy.
Okay. I'm going to skip that one. Let's do this one, guys. Again, I'm going to give you a few minutes to look at it and to orientate yourself with the question. See if you can do the similarity. And also, let's do some marks with that one. This one. So this is, let's give it, yeah, so what did I say?
Nice. So now we have the mark there. Nice, guys. This is over 8 marks.
Yeah, so let's use this as a little self-assessment. I know you're going to do your quiz today as well,
Yeah.
but use this as a little self-assessment to see if you can prove the similarity and then jiggle the sides around to get what you need.
Definitely. Let's go, my people. Morena, do you have a question? I see your mic is on. If you have a question, please do ask. But I think Miss B here has given us a chance to prove herself. It will feel so good to see how many marks you get, and then you can see the corrections and you can mark them. So it will be really awesome to see that. But y'all guys are doing amazingly well. But if you are stuck, please do let us know in the chat. We'll definitely give you like some hints of where to start.
Yes, guys.
Remember, when you're done, you can just put it on the chat. So you can just say done, like this. Miss B and I can see that how many of you are done. But we are all giving it a try, my people.
I'm going to give it one more minute, Miss Yolanda, and then I'm going to just flick to the answer.
Okay, no problem, no problem. I see also that the time is like ticking, ticking, ticking.
Yeah. Okay. I think I'm here at the answer. Was this the one? It's the same one, hey?
Yes, it was definitely the same one.
Okay. Alrighty, guys. So to do the similarity proof, again, read what's at the top. It says PB is a tangent to the circle, so immediately think tan chord theorem. And PA is parallel to BC. So PA parallel to BC, lovely. That helps us with angles, finding angles that are equal. So highlight your two triangles. You've got triangle PAB and triangle ABC. You can do B1 equal to C, angle C. That's because of tan chord theorem. And you can do A1, angle A1 equal to angle B2. That's because of alternate angles, AP parallel to BC. Remember, you have to put that AP parallel to BC. And then lastly, because we've got those two angles now, we can say that angle P is equal to angle K2, angle sum of a triangle. Once you have the similarity, so write down your triangles are similar, and then write your reason. So if you want to give yourself some marks here, and please tell us in the chat how you did. One for the alternate and the tan chord and the angle sum, and then for the similarity with the reason. How did everyone do? Did we get some marks here? Anyone get 4 out of 4, 3 out of 4? Tell us how you did. Nice, Nolutando. Well done.
Well done, Nolu. Well done. 4 marks. Katleo, that's still halfway. As long as you've seen where you made your mistake, that's okay.
Make some
That's
corrections.
Yeah. Okay, so no worries. No worries.
Okay. Yo, guys, make your corrections, understand where you went wrong. And then for the next question, PA to AB is AB to BC. So you set up your sides using your frog face. So those are the sides that are in proportion. And in fact, just this first combo with PA over AB and AB over BC, that already gives us our answer. We just need to rewrite it as a ratio. So there's 2 marks. Anyone got 2 out of 2 there? Let us know. And then lastly, we need to do AP over BP, AP over BP, and AB over AC. And so we just use the next combo, the combo that are circled in red. So that's PA, AP, PA is fine, AB, AB over AC. And here we are going to have to, what do we need? We need AP over BP. Oh, I wrote it wrong. Sorry. Let's just fix that one. PB over AC. So here we're just going to have to cross multiply. We need the PB with the PA and the AB. So basically they have to swap. So it's almost exactly the same as the previous question. So we just go PA times AC is PB times AB. And then we just divide again to put the sides where we want them. AP over BP. And AB over AC. And that's that. So writing it like that and then doing the final, that's another 2. Okay, so give yourself another 2 marks. Anyone got 8 out of 8? Let us know.